Hello guys, welcome back. So here we have another question on network theory from GATE 2017. The switch in the figure below was closed for a long time. It is opened at t equal to 0. The current in the inductor of 2 Henry for t greater than or equal to 0 is, so they are given 4 options and this is the circuit. So this switch is been closed for long time. So you need to find the current through this 2 Henry inductor and after that it is opened out. So then you need to find the time constant of the circuit which will give the rate of decay. So with these two parameters you will be able to find the answer. Okay, so let us solve it. Okay, so initially if you see this switch is going to be closed for t less than 0. So when it is closed for a very long time, this inductor you can assume it as a short circuit, right? So I'll draw like a short circuit. So once this is short, these resistors goes away because this is in parallel. And if you see this 32 ohm also is nothing but it is parallel here. So it is nothing but it is sitting in parallel between these two nodes only. See, these are the same nodes. So these both goes away, right? Because whatever the current coming here, all current flows here only because of the short circuit. So effectively what this resistance becomes equivalent resistor. It is 8 ohm in parallel with 8 ohm. So this becomes 4 ohm. So what is this current I1? I1 is equal to 50 volt by 6 ohm plus 4 ohm, which is 50 by 10, which is equal to 5 ampere. So this is equal to 5 ampere. And if you see these two resistance are equal. So our I is going to be equal to I1 by 2. They are going to split equally. So this is equal to 2.5 ampere. And all this 2.5 ampere flows through the inductor, right? So your IL of 0 minus is equal to 2.5 ampere. So now you again take the circuit. Now we will consider the case for t greater than or equal to 0. So here what happens? Here it is opened out, right? So once you opened out, this part of the circuit doesn't matter. So we can remove this. We are not interested in this. Okay. So now what is the initial condition for the inductor? So inductor current cannot change instantaneously. So IL of 0 plus is equal to IL of 0 minus is equal to 2.5 ampere. And finally what will happen? Since this is a only R and L circuit without any sources to provide energy, eventually this current will die out. So you can say your IL of infinity is equal to 0. So how will the decay look like? So the decay will be exponential because it is a single RL circuit, right? It has a single pore. So it will be of the form of 2.5 e power minus t by tau. So we are left with only to find tau. So tau is nothing but your L equivalence by R equivalence. So we just need to find R equivalence from this circuit. So if you see, you have 8 ohm, another 8 ohm, and 32 ohm, and 32 ohm, and you want this equivalent, R equivalence. So this is going to be equal to 16 ohm, and this 32 in parallel with 32 is 16 ohm. So your R equivalent is 16 ohm in parallel with 16 ohm. So which is equal to 8 ohm. So your tau is equal to, from here, this 2 Henry by 8 ohms, which is 1 by 4. So what will be your current? Your IL of t for t greater than or equal to 0 is equal to 2.5 e power minus t by tau, and your tau is 1 by 4. So your IL of t is 2.5 e power minus 4t. So this is your answer, which is option A. So this is again a very simple question and the answer straight away follows from the basics.